Hey everyone, we're going to be talking about solving exponential and logarithmic equations, and there are two types of equations that we're going to be looking at for each. There's the simple kind and the complicated kind, okay? So ideally with either one, in the first video here that we're going to be talking about is exponential, we're going to be looking at simple and complicated. For a simple exponential equations, the first part here is really key. We can rewrite both sides of the equation in terms of the same base. We use this idea of the one-to-one property, and then solve for the variable. When we get to the complicated portion, it looks a little more challenging. We isolate the exponential expression, and then you have to take the same log of both sides, simplify, and then solve. So these are the ideas and strategies that we're going to be using in both these videos. The second video for solving logarithms, it's really the same idea. Okay, but let's get to some examples. Before we start, however, we want to look at what is a one-to-one property. Well, the idea here is if you have two bases that are the same and they're raised to a power, this can only happen, b of x equaling b to the y can only happen if and only if x equals y. And same thing with the logarithm. Two logs with the same base, log base b of x equals log base b of y. That can only be true if x and y are the same. So this is the idea that we're going to take into our examples. Okay, so let's look at three examples here. Solve each equation below. So the idea here is we're first going to look at rewriting the base. So we have this nice 3 to the x, okay, and we know that 81 is just 3 to the 4th power. Okay, so there's rewriting the base. So this is a simple example. Okay, so the bases are the same. Well, that means the one-to-one property says, well, the exponents are the same. If these two things are equal, the bases are the same, that means the exponents have to be equal. So in our second example here, we can just leave 5 to the 7 minus x alone, and we're going to rewrite that here below. And then if we want, we know that 125 is just 5 cubed. Okay, so we can go ahead and do that. Now, the one-to-one property, we're going to say, hey, if the two bases are the same, well then the exponents have to be the same. And so we have 7 minus x. Okay, and that the idea of that is the property of equality. So we have 7 minus x equals 3. That means negative x equals negative 4. And so x equals 4. Okay. Now in the last example I really like, we're actually going to rewrite both sides here. We have 1/2 to the 4y power equals 16. Well, we can rewrite this as 2 to the negative 4y. And the reason I'm doing that is because I know that 16 is just 2 to the 4th power. Two bases, they're the same and they're equal. That means the exponents have to be the same. So negative 4y equals 4. That means y is going to equal negative 1. So those are what we would call our simple examples. Okay, so let's move on. What happens when we look at examples that are not simple? Meaning the bases can't be written the same. If we could get to page 2, and it apparently does not want to go to page 2. Oh, we want to go to page 3. There we go. Here's page 3. All right, so now solve each equation. 5 to the 3x equals 16. Now, 16 is a multiple of 2. 5 is not, so now we're in a little bit of trouble here. So we have to think, well, these are not simple examples, okay? So what we're going to end up doing is taking the log of both sides. Now, you can do logarithm. Most commonly, people take the natural log of both sides. So we have the natural log of 5 to the 3x equals the natural log of 16. Okay, and then our properties tell us we can swing that 3x out front. We're going to times the natural log of 5, and that equals the natural log of 16. So now we're going to end up using our graphing calculator. If we want x by itself, we're going to have x is equal to the natural log of 16 over 3 times the natural log of 5. Now be careful how you enter this in your calculator. And we're going to get approximately 0.5742. Okay, we're round to 4 decimal places there, and that's our solution. So this is one that's more complicated. It involves taking a natural log of both sides of the equation. So here's our next example, 4 to the 3x plus 2. Again, 4 is a multiple of 2, 71 is not, and we're not going to be able to rewrite these with common bases. So my first step here is to take the natural log, okay, of both sides, okay, if I wanted to. The other option is I could just, no, I screwed up. How do I pause? Command Shift. Okay, so kind of made a goof here, but we can take the natural log of both sides or the log of both sides. So if I take the ln of 4 to the 3x plus 2, okay, equals ln of 71, okay, we are going to have 3x plus 2 times the natural log of 4 equals the natural log of 71. Okay, that's got to be in parentheses, that whole thing. So then we will take, 71, and then we'll divide each side by ln of 4, so we get 3x plus 2 is equal to the natural log of 71 over the natural log of 4. Okay, you subtract 2 from both sides, divide by 3, so we'll just do 3x equals the natural log of 71 over 4 minus 2. Okay, and then this whole thing would be divided by 3, the whole thing here. Okay, so x is going to equal the natural log of 71, forgot that natural log there, over the natural log of 4 minus 2. This whole thing would be divided by 3 or times 1/3. Okay, going to run out of space, so x is approximately, when we put all that on the calculator, 0.3583. So that's a tough one. Okay, so let's look at our last set of examples. Okay, we've got 2 here, 4e to the x squared. So the first thing I want to do is divide each side by 4. So I have e to the x squared equals 16. Okay, and then I'm going to take the natural log again of both sides. So natural log of e to the x squared, okay, equals the natural log of 16. Okay, so we're going to be left with just x squared, the natural log of e, they're inverses, so x squared equals ln of 16. So x equals plus or minus the natural log of 16, okay, and that's square root, right? Okay, so that's going to be approximately plus or minus 1.6651 if we actually did the square root of the natural log of 16. Okay, so that's your answer there. Finally, our last example, complicated, and it's a quadratic. Okay, so the idea here is we can let u equal e to the x. Okay. Now, e to the 2x is just e to the x times e to the x, okay? So when we rewrite this, this is going to be u squared minus 4u plus 3 equals 0, okay? So we're going to use u to kind of help us out with this e because it can be confusing to factor. So this looks like a quadratic, and we're going to go ahead and factor this. Two numbers that multiply to be 3, add to be -4 are minus 3 and minus 1, so u minus 1, that equals 0. So u equals 3 and u equals 1. But we know what u is. U is e to the x. So we have e to the x equals 3 and e to the x equals 1. Okay, so now we have to solve these equations by taking the natural log of both sides. So the natural log of e to the x is just x. So x is going to equal the natural log of 3. Okay, or x is going to equal the natural log of 1, and we know that the natural log of 1 is 0, so x equals ln of 3, or x equals 0. So those are some additional examples of how to solve exponential equations that are both simple and complicated bases. If you have any questions or comments, you can type them below. We'll see you next time.